Welcome to the lair of the Batty Boffin.
Hi there Batty fans, it's time for a little bit of GCSE exam practice with the Batty Boffin, helped as always by Batilda the Batty Cat. Now today we're going to be looking at a question that several people have been asking me about. It's one known as Hannah's Sweets and it's on an Edexcel past paper. Now I am not going to do that exact question. I never do exam questions, one for copyright and two because having the answer given to you will not help you to learn. However, I will do a question that is incredibly similar and this one's called Batilda's Sweets. So Batilda has a bag of sweets, here it is. There are n sweets in the bag, of which 4 are red. Okay? We know that if Batilda takes a sweet and eats it and then takes another sweet, the probability of both being red is 1/6. So, using that information, for part A, please could you show that n squared minus n minus 72 equals 0, and for part B, find out how many sweets are in the bag. Now, this is quite a hard question. This is high level GCSE. If you're not in Britain, then that's whatever the exams are that you take at 16 that are the hard ones. So a tip on here, if you're not quite sure what to do, try writing down anything that's true that's got an equals in it, and hopefully when you got a few of those, inspiration should strike. Okay, I'm going to pause the video here and I'm going to come back in a couple of minutes and look at part A. Right, here we go with part A. We're going to try to derive this quadratic, so we're going to need some things that have got n in them. Well, here's one for a start. The probability of the first sweet being red, I'm going to call that red 1. The probability of that is the number of red sweets, 4, out of the total number of sweets, which is n. Okay? Now, if the first sweet was red, then what's the probability of the second sweet being red? By the way, we don't need to consider the case where the first sweet wasn't red because we only know the one for when it's red and then red the second time as well. So the probability that it is red the second time, I'm going to call that red 2, is there are now only 3 red sweets left out of a total of now n minus 1. By the way, if you wanted to draw that on a probability tree diagram, that might be a way you like to do it, then it would look like this, with red and not red, and the same here. Probability of getting a red the first time is 4 out of n, and if you got a red the first time, then the probability of getting one the second time is 3 out of n minus 1. And we don't particularly need to fill in the rest of them because we're not interested in those bits. We're only interested in this route through, and we're told that that comes to 1/6. So from that, we can write this equation. Probability of red the first time and red the second time comes to 1/6. Okay, so that's getting a red on the first sweet here and getting the red on that second sweet if you got red the first time, and we know that that's red and then another red is 1/6. Okay, that we can simplify. So if you didn't manage to get this far, pause now, simplify that and see if you can get the quadratic. Right, here's the equation we had, and we're going to try to turn that into the quadratic required. First thing I'm going to do is multiply out this left-hand side here, so just fraction multiplies. We get a 12 over an n minus 1. I'm going to multiply that out, but I won't do that quite yet, I think. And that is equal to 1/6. Then I'm going to multiply both sides by 6, which gives us 72 over n minus 1 equals 1, and then multiply both sides by whatever's on the bottom of the brackets. Oh, keep doing that, don't I? There we go. Gives us 72 is equal to n minus 1, and then we multiply these out and I'm also going to subtract 72 from both sides. Okay, so when we multiply that out, we get our n squared minus n. I'm going to subtract 72 from both sides, and that equals 0. Actually, it's an equals 0 on that side, but I've just written it over here. And there, ta-da, is the quadratic we were looking for. Okay, so that is something that we've got in terms of n, and n, of course, you remember, is the number of sweets in the bag. So in order to find out how many sweets there are, we need to solve that quadratic. Okay, here's another pause in the video for you. See if you can solve that. Right, here's our quadratic. There are several ways you could solve that. You could use the formula if you want to, although it does actually factorise rather nicely. And you can have a guess that it factorises because we need the answer of a number of sweets, which has got to be a whole number. And quadratics with whole numbers factorise. So we're going to factorise this. If you're not sure how to do this, check out other Batty Boffin videos on the quadratics playlist which tell you how to do this, but I'm going to assume you vaguely know what you're doing and I'm going to zip through it here. So we have got a coefficient of 1 here, coefficient of -1 and -72 for the constant. Now this is the easy type of quadratic, which means that we've just got an n at the beginning of the bracket both times, because that's the only way of getting n squared. And we are now looking for two numbers that go here, which add to make -1 and multiply to make -72. Again, if you're not sure why, check out the Batty Boffin videos on factorising quadratics. But assuming you're okay there, what I've done is I've lifted out all the factors of -72. There are sadly a lot of them. You've got -1, 72, and normal 1, -72. Please remember they always come in these pairs with the signs the opposite way round. With a bit of luck, you might have actually spotted them. Things that multiply to make -72 and add to make -1, which means they've got to be different by 1, because of course one's got to be positive, one's got to be negative, and of course we have 8 9s are 72. 8 9s are 72 and they differ by 1. So adding to make -1, it's going to be, it's the very last ones down there. These two numbers add to make -1 and multiply to make -72. Quick check on there just to make sure I'm not lying to you. When we multiply these out, we have the first 2 gives us n squared, the outside 2 gives us -9x, the inside 2 gives us plus 8x, and the last 2 give us -72, which is what we wanted. Those two there, of course, combine to make that. And this is my dragon claws, so I'll put in a drop of blood. You don't have to put the blood in. It won't get you extra marks in the GCSE, but it might make your examiner feel a little happier, so that's always a good thing. A little drop of blood there. There we go, lovely. So, having factorised it into that pair of brackets, we have a bracket times a bracket equals 0, so that means a number times a number equals 0, therefore one of those two numbers must have been 0. If the n plus 8 was 0, then that would imply that n was -8. If, on the other hand, the n minus 9 bracket was equal to 0, then that would imply that n was equal to 9. Since we want a number of sweets in a bag, we obviously want a positive number, so there is our answer. N is 9. There were 9 bags in the 9 sweets in the bag. Okay, so that is the end of Batilda's sweets. If you have been struggling with that wonderful question, becoming legendary now, of Hannah's sweets, you do it in exactly the same way, just different numbers. So go and have a go at that now, and I will see you in another Batty Boffin video. Bye for now, Batty fans.